Okay, a cube is cut into two pieces by a single slice that passes through points A, B, and C. So we're going to take a big, long knife and we're going to slice diagonally from A and B. Oh, I keep touching it before I'm ready there. Okay, from A and B down through C. So we're going to get a slice like this. And some of you drew that very nicely. What shape is that slice? What shape is the slice?
A square.
Yeah, it's probably not a square because it's definitely not a square actually because it's a cube. So when we slice the cube, it's actually going to be longer from point to point than it was from here to here. Up on my board, it does look like a cube, but we would, or not a square. What can we call it if we're not sure the sides are the same way?
Rectangle.
Rectangle. So you should say a rectangle. Yes, Mason.
I brought a triangle because I see two triangles there when I cut.
Okay, so you're seeing like you have a triangle up here and a triangle.
I am seeing I have a triangle, like one here, one there.
Okay, I see what you're seeing, Mason. So if you cut it in half, what happens is you would end up with two triangular prisms. That's the three-dimensional shape that you would end up with when you cut it in half. But this two-dimensional, like say this cube was painted blue on the outside. We sliced it open. The part that's on the inside maybe would be white because we had never painted the part on the inside. We're just talking about what shape is that flat white part. Okay, so there's just the face that would be exposed. I'm glad you pointed that out because I think that's a common thing that people do wrong. Okay, so this is asking us how we would slice this three-dimensional figure to result in each cross-section. So if we want to get a triangle, we're going to have to slice it parallel to one of the triangular bases. So we would need to slice starting at the tip and slice straight down. So to explain that, you might say start at the vertex and slice vertically. Start at vertex and slice vertically. If we wanted to get a trapezoid, we would also slice vertically. We would make a vertical slice, but instead of starting at the tip, we would do what we did in the last problem. We would start here and then slice straight down, and we would get a trapezoid. So you would want to start somewhere other than the vertex and slice straight down. Start somewhere other than vertex and slice down vertically. Okay, make sure if you did not have the correct answers that you write the right answers in your notes so that you can use these to study for quizzes and tests. Does anybody need more time on this, or does anyone have questions?
I do.
Okay, I'm going to pause this while you write. So we have two three-dimensional figures. It asks us to describe a way to slice one of the figures so that the cross-section is a rectangle. It's only going to work for one of these shapes. If we look at both shapes, which shape actually has a side in the shape of a rectangle? Only one of them has a side. Yeah, shape A has some rectangular sides. It has this bottom side, and the two sides are also rectangles. B doesn't have any rectangles in it, so it's going to be a lot harder to get a rectangle. But if we were to slice A horizontally, look at what happens. If we were to slice here, okay, if we were to slice here, and we were to slice straight back, we would have a slice that looks like that, which is a rectangle. You see that? If we were to slice it down here, we could get another rectangle, but this rectangle would be a wider rectangle. If we sliced all the way up here, we would get a really skinny rectangle. So we could cut lots of rectangles from our triangular piece. They would just keep getting skinnier and skinnier. I have more in my desk drawer on the right.
I thought Haley needed one.
Okay. The next problem says each row contains the degree measures of two supplementary angles. Complete the table. So supplementary angles add up to 180. If you forgot that, you could Google what are supplementary angles, and it would come right up and tell you that. So supplementary angles equal 180 degrees. So to find the measure of an angle supplement, we have to do 180 minus the angle. 180 minus 80 is 100 degrees. So its supplement would be 100 degrees. 180 minus 25 degrees would be 155 degrees. 180 minus 119 would be 61 degrees. 180 minus x would just be 180 minus x degrees. We don't know what x is, so we can't actually subtract it, so it's okay just to write that as an expression.
I'm going to express my feelings.
Okay. Number 5, we're going to go over, but it was a tricky one. Does everybody get number 5?
No. Yes,
This one. Okay, 2 months ago, the price in dollars of a cell phone was C. So we don't know what the cost was. We're just using C to represent it. So the cost was C. Last month, the price of the phone increased by 10%. Write an expression for the price of the phone last month. So if it increased by 10%, we're going to take this amount, which we could call 100%, and we're going to add 10% to that. How many percents do we have if we add 100% plus 10%? 110%. So if we have 110% and we multiply that times C, we'll get the cost of the phone. How would we change 110% to a decimal? What would it be as a decimal? You need to move the decimal place over 2 to the left. Jocelyn? You're moving it too far. The decimal's here right now. Haley? 1.1, yeah. So we could write this as 1.1 C. That would give us the new price of the phone. Now, letter B says, this month, the price of the phone decreased by 10%. So this is our new 100% right here. 100% now is whatever the phone was last month. If it decreases by 10%, what percent is left? We're starting with 100%. We take away 10%.
90%.
What's left? 90%. So now we have to find 90% of this. The word of tells us we would multiply, so we're going to take 90% times 1.1c. So we have to do 0.9 times 1.1, and when we do, we get 0.99c. So now it asks us, is the price of the phone this month, is this the same as it was 2 months ago? Is that the same? C and 0.99c?
Yes.
No? If you have 100% of something 1 month and you only have 99% the next,
Oh.
you don't have the same, right? It's really close. But this is kind of weird, isn't it? That it could go up by 10% and then down by 10%, and it doesn't end up being exactly the same price because it's going down 10% of the new price, not of the old price. So it's kind of a strange way that it works out. If they had taken it based on the old price both times, we would have ended up with the same price. Okay.